Okay. So I'm waiting on Fallon to tell me what which particular ones. So all right. While I'm waiting to get a response back, um, are they are there any ones in 2.4 that the rest of y'all need to see? Let me grab this while y'all were. Okay, I can't get nothing from Fallon, so let's see who else is there. Aaron, Amy, y'all have anything y'all need to see in chapter 2?
My problems are only with a few questions in 1.3 right now.
Okay. You want to look at those or?
I guess we can wait for Fallon if we
Yeah.
need to, or
Well, I asked a question. I've done it verbal and I've done it on chat, so I'm just waiting for her to respond. But she might be preoccupied, so we'll just move on. Just something to pop up if she comes back to.
I have one question so far that I'm working on 2.4. It's number 5.
Yeah. All right.
So that
So you basically are saying, what does X and Y have to be to make this true? And it's not a really. It's probably one I ought to take off. Period. Because it really just is not a good question. So I can show you how to do it. So we're sitting here. Let's see. So we need to make this statement. We need to find out what X equals and then what Y equals to be able to make this statement right here true. So if I have -9 times what would equal 3? Well, so what we've got is, what times -9 give you +3? So that'd be a -1/3, right? Basically, you are setting, if you do this, if you want to think about it like this, -9 times what equals 3? So divide by -9. So X has to be negative. That didn't look good. X has to be -1/3, right? And then, of course, yi equals I. So, well, it doesn't need the I. Let me back up on that one. Y equals 1. So, so at Y is 1. I mean, it's nothing we have to do with that one. So your X would be -1/3 and your Y would be 1. For the one that I just did. Does that?
how did you find how do you know that the Y is 1?
Well, see the coefficient right here of the I?
Uh-huh.
It's 1. So basically what I'm doing is I'm setting this part with equal to that part, and then let me grab another color. So I'll take this coefficient, set it equal to that coefficient. When I do, you can see that it's just one y. So there's really not anything I have to do with that one. But do you see how, like this one right here? Let's
Yes.
circle it. I took negative 9x, it's got to equal 3, so I solved for what x had to be, and it had to be negative 1/3. But on this one, there's nothing to really solve because y is 1. I'm not making it do anything. So
Okay.
okay. I can make that one go away. So
Okay.
I don't have a pen, but yeah, dude. Let me see. So we're going to take section 2.4, number 5. Okay. All right. Got it. Just make my notes.
Okay.
I'll go back through and kill it afterwards. But
Okay. Thank you.
It'll. Fallon said, just pick a few in 2.4 and the I stuff. Okay. So I don't know. I-22. I guess that's what she's wanting. So I'll find the one that would be, right? So remember that you are basically I to the first equals I squared equals -1, I cubed equals negative I, and then I to the fourth equals 1. So I'm basically going to write this I to the 22 as being I to the fourth raised to some power. So 4 going to 22 at least 5 times. And so 4 times 5, power to power, property of exponent, will give me 20. So I have 2 left over, right? So this is really 1 raised to the 5th power, which is just 1, times I squared is -1. So your answer is -1. It's basically whatever this right here is what's going to be your answer, seeing as you've written it in powers of I to the fourth, which is just 1, right? So that's how you do those. Any other ones y'all might have, or let's see. Aaron, you want that?
Yeah. Number 14. Actually 16, 17, 18, and 19 as well. For some reason I got 15 right. I think I might know what I'm doing wrong though.
All right, so let me
go over it anyways. Fine.
Okay, so tell me the first one, or the one that you think you've got right, but are you
14? Yeah, 14.
14. Okay. Use the product property of radicals to simplify this. Let me go here. And so the easiest way to do this would be, we know it's to the 4th power, right? So we have to find powers of 4s that would go into 8 to 48, right? So what we have to understand is this, and this is what I was doing the other night in class. So I was going 1 to the 4th equals 1. 2 to the 4th is equal to 16. 3 to the 4th, I don't know what that is, but I'll get it real quick. Let's see. That is 3 raised to the 4th is 81. Okay, now, 81 is above 48, right? So I don't have to worry about that one. Really, the only one that I have an option of being a factor to be able to simplify this would be 16, which is 2 to the 4th. So what I need to do is this. I will look at the 4th root of 48, and then I'll do this right here, a to the 11th b squared. And then what we'll do is we'll say, okay, that is really the 4th root of 16, and then let's see, 48 divided by 16 is 3, and then that would be the 4th root of 3, right? So we know that the 4th root of 16 basically simplifies to nothing more than 2, right? So that would be 2 times the 4th root of 3. That's how the number part of it breaks down, right? So, any questions about that? I think that kind of was thrown.
No, my main problem is like making the A and B on the right sides.
Okay.
The pairing, I guess.
Yeah. I can show you 2 trains of thoughts here. So you can let me do this. Go A times A times A times A times A times A times A. That's 4. Let me kill this over here.
So you have to, if it says for the root of, like the 4 root, you have to do in pairs of 4?
Yeah.
Whatever that is? Okay.
Yeah, so this is expanded out, right? So this tells me that I need to have groupings of 4 in order to bring one of those out. So if you think about this, there's one grouping. Here's 2 groupings. I don't have another one left over, right? So I could bring 2 of those A's out. So that would be 2A squared to the 4th of 3. Now, let's see if we can't pull any B's out neither, can we? So that would be 3 A's and 2 B's left over.
Okay.
Now, that's expanded. So, but I can say, how many times will 4 go into 11? Well, it'd go twice, right? So that's where this number comes from. And then how many are left over? 3, and they're back under here. And 4 doesn't go into 2 because that number's less than 4, right? Does that make sense?
Yeah. I think I just got confused with the pairings.
Yeah.
Because I think I was doing the pairs of 2 at first. I didn't realize you had to do 4.
Yeah, the root tells you what your pairings have to be. Basically, how many times will that root go into the exponent that's on the variables? And we get so comfortable, so used to looking at square roots, when we change roots, you go into 3s or 4th roots, cube roots or 4th roots, it kind of messes with us because we just take for granted. We're just kind of ingrained to look at square roots, right? But we can do it with other roots as well. But this would be your final answer on the problem that I just worked. So.
That's a lot better. Thank you.
Yeah. So if you ever want to, the 4 goes into 11 twice and then 3 left over here, and then it won't go into B squared. If you ever get in doubt and you want to expand it out like this, it's this expanded form really leads to no errors. I mean, you kind of see it. So, but either way is fine. Doesn't really matter. Any more in that one, or Aaron, do you want to see? I mean, not Aaron. Aaron, any more on that, or I think Amy's with us. Fallon's at work, so she's just kind of.
Yeah, I'm good on that one. I did have some other questions, like Aaron, I think, wanted to do 15 through maybe 18 or something.
Yeah, I actually like 15. Well, 6. Yeah, we could do like 15, 16, 17. I'm having a problem with the fraction ones, like 19 too. I didn't even attempt it because yeah.
Okay, so we'll look at this one. We'll do
Okay.
15, and then we'll do 16, and if y'all want to do 17, we can do it too. Doesn't really matter. We'll take by request. So, all right. So let's kind of look at this, make sure. All right. So it's a fraction underneath. So what we need to understand is we need to write this as a. We can rewrite it as this. Well, let's do this first. It may make it a little bit easier. Well, it will make it a little bit easier. Let's go ahead and take care of this right here. Let's don't worry about the numbers per se, because 169 and 196, they're perfect squares, okay? So I'm not concerned about that. But if I leave the b in there, when I split it, it's going to make it where I have to rationalize. So let's kind of do this. 169 over 196, and that's b to the 3 minus 1. So what I'm doing is I'm doing the quotient property of exponents. So that's really going to leave me as 169b squared over 196. Now I can say, okay, that's 169b squared over 196. And that just gives me back perfect squares. So it gives me 14 here and 13 for the numbers. And of course, 2 will go into 2 one time. So that's going to be your final answer. So I chose to do the quotient property of exponents on this particular problem first before I split the radical. Okay, does that make a little bit more sense? I guess you could.
Will it let you do another one similar to that?
Yeah, you want to do another one similar to that?
Yeah, just so I'm sure on it.
Okay. Let's see. All right, I'm going to hit submit. Oh, shoot. Okay, so I'm going to try another one, right? So there you go, right? So it's algorithmically generated, right? So the setup is going to be the same, and that's what you got to make sure you understand. We're still dealing with perfect squares, are we not?
Yes.
All right, so we just had this. Oh, shoot. Okay, there we go. Go here. We can actually do it this way if you want. There's a 1, right? So we know that this is going to be 169 z to the 2 over 100, right? Because if I got 3 up here and 1 down here, they cancel one of them out, right? So that becomes a 2, and then this becomes what? Goes away, right? Does that make sense?
Yes.
Okay. You think of it like this. I got 3 z's up top, 1 z on the bottom. I cancel it out, right? I got 2 left. So that's really what the quotient property is. So now I can split it up. So the bottom becomes a 10 because square root of 100 is 10. And then square root of 169 is 13. And of course, the square root of z squared is nothing more than z.
Okay. Thank you.
Yeah. So, yeah. All right. So let's go see what else y'all want. Let's see. 16. All right. So this one's a little bit different. You're going to have to rationalize it, right? So that's going to be And before I do that, let me just see. 80 divided by 15, is that? No, it won't go into it. Yeah, I guess I could do it. I could simplify it. That's okay. We'll just deal with big numbers. All right. Got 3 notebooks open. How did I do that? Okay. So here we go. Let's see. We're going to rationalize this. So what we need to create is really, well, let's just go ahead and split it. 80 over 15 of x, right? So I need to create out here. I definitely know I need to have an x squared, right? Because I got 1x here. In order to get it to come out, it has to be groupings of 2. So we definitely know we have to have an x there, right? Then, of course, to make a perfect square, just times it by 15, right? So you basically rationalize it by the denominator, which would create a perfect square. But I want you to kind of, when you get to like 4th roots and stuff like that, you have to ask yourself those questions. What do I need to rationalize it by to create that perfect root? In this case, it's square root. So we'll have this up top. And this gives me, was that 225? And so that's 15x, right? So, and then 80 times 15 is 1200. And 1200, let's see. Oh, yeah, I can. Okay. So we're going to simplify 1200, right? Now, x won't, right? There'll be an x. Well, can't do that yet. There'll be an x underneath the radical over there because x is to the first and there's a 2 right here. So 2 won't go into 1, right? So that x, it has to stay underneath that radical. But let's do the square root of 1200. And if you think about it, that's the square root of 12 times 100, right? So if we look at this, then this is 10, right? And that's that. So it's 10 square roots of 12. And if I go back and look at this, really I should have done it by 400, right? Which would have been 20, but all right. So this is square root of 4 times square root of 3 times 10. But that would be 10 times 2 times square root of 3, which is nothing more than 20 square roots of 3, right? You all good with that? You could have picked 400 if you wanted to. You'd had 400 times square root of 3, and of course we know that would have been 20 square roots of 3 if you would have went there first. But so we're going to take this up here, 20 and 3x. Now we've simplified our radical. We know that's good. Now let's simplify our fraction between this, which is what to go into 20 and 15. So that's 5. So that's 4 3x over 3x. There you go. So what's your thoughts? You good?
That looks good. Yeah, that looks good. For any reason, the 3x and 3x, they cannot cancel out, right?
That is correct, because one's underneath the radical and the other one's not.
Okay, thank you.
The only thing that you can look at 3x with is what's out here. That's it.
Okay.
So, and you can't do anything to those, so we're good.
Okay.
All right. Aaron, you good with that?
Yeah, I'm great. Thank you.
All right. You want to see another one, or you want to go to another problem?
I think I'm good. I have another problem.
Okay. That was problem number 16. What ones you want to see next? We got 17, 18, 19, 20 through 25. So y'all
We can just do 17 and 18 for now, if that's okay.
All right. Okay. We're just rationalizing these. And I'll give you some things to consider before we start working. These is just kind of step back. It's a square root, right? So there's a 2 sitting right there. Now, can I simplify these numbers right here evenly? 75 divided by 2. 75 is an odd number, so it's not going to go into it evenly. So I'll just something to check before you get started, because it may simplify and make things a little bit easier. And this is a y to the first, and I can't do anything with properties exponents there, so that's kind of where I'm left at. Now I can start to break it up. So I'm looking at 75x cubed over the square root of 2y. This one's very similar to the one we just worked, which is I need to create a perfect square, and any way to create a perfect square is to multiply it by itself. So that's why we're going to do this like that. Okay. This would give us, let's see, this would give us 150 x cubed up top, y, all over the square root of 4y squared. Now, that cancels down to 2y. Oh, crap. Okay, 2y. Now, we got to look at this. We've got to take 150 x cubed y and simplify it, right? So 150, well, I can do square root of 25, and I don't know, what is that, 6 times, I think. And then we can do, so that's 5. Now I can pull out 1x, but I can't pull out a y, so that's going to leave 6xy. Okay. Remember, there's a 2 right here, so 2 goes into 3 one time, so brought 1 out and 1 left over, and 2 won't go into 1 because it's less than that. So just kind of be mindful of that. Now this will all go back up here. Well, that's wanting to change like that. 5x. I am hitting something that it does not like, and I can't figure out what the heck it is. 5. All right. Okay, guys, it's just, I don't know why it's moving. I can't figure out why it's moving like that. Square root of 6xy, and I can't simplify anything right here, so I'm done. Okay. Isaac, give me a paper, bud. Find me a charger cord for that. Maybe on the back of the stairway door. Take this with it, please. It's a little bitty one. Thank you. All right, guys. Any questions on that?
No, that looks good. Thank you.
Okay. You want to do another one below? 18. That's a cube.
Yeah, let's do that.
All right, so I'm looking at perfect cubes, right? So none of these are perfect cubes. So, and I can't simplify between them before I go, right? So, now let's consider, what do I need to rationalize it by to get? Did I burn it? Don't need that. There. I need cube root of 5x over the cube root of 4y. Now, what I need to rationalize it by, I know it's got to be a y squared, because if I got one here, that's
Samsung, it goes in it.
yeah, plug the lamp off, buddy. Okay.
Which one's the lamp?
Just unplug one of them, you'll see. So what would be a perfect cube for that? And it would be 4 cubed. What would 4 cubed be? 64. Let me make sure that's true for my brain.
16 times 4.
Yeah. All right, so I need to multiply this by, this is what I'm rationalizing everything by. Any questions about that before we go on to anything else?
No, I think that's good.
Aaron, you good with that too? All right, so we're just going to multiply. This is going to give me, of course, the cube root of 64y cubed. And then 5 times 16, I think is 80. Yeah, so that's going to give me the cube root of 80xy squared, right? So, let me move this back here. All right, so let's see. This is just going to be 4y, right? So, can I find something that will go into 80 that's a perfect cube? Well, you've got, let's just do it right here. That's 1 cube, 2 cube, 3 cube, 4 cubed. So that's 1, 8, 27, 64. 8 will, right? So I can take the cube root of 80 and break it down into the cube root of 8 times the cube root of 10, which would be 2 cube roots of 10, right? You okay with that? I can't do anything with my variables because 3 won't go into 1 and 3 doesn't go into 2 because it's not above 3. So this is going to simplify down to 2 cube roots of 10xy squared. And then all I have to do is just simplify this, right? Which will give me cube root of 10xy squared all over 2y. All right, y'all good with that?
Yes.
All right.
Keep up for just one more second, real quick. Sorry.
Yeah, no problem.
Okay, I'm good.
I'm going to switch headphones anyway. So, all right, so let me go here. And then let me go here. All right, can y'all hear me?
Yes.
Okay, good.
Yes.
All right, I can hear you a little bit better. All right. So where do y'all want to go now?
17. Let's see. No, where are we on? We're on 18.
Mm-hmm.
19 was my last one.
Okay, yeah. This was a tough section.
Well, you're getting into rationalizing, and it doesn't just stay with rationalizing square roots. It jumps to cube roots. It starts throwing in everything but the kitchen sink. So
Right.
it's requiring you to be kind of up on the skills necessary to kind of look at it and tackle it and keep going. So if it's been a while since you've done this, yeah, the struggle is going to be real.
Okay. Yeah.
But just working them, and once you get one like right, kind of what I was telling, I can't remember if I was telling y'all's class or the earlier class, but try to get through the homework to get your 100, and then go back and as you're progressing through, just kind of write down like question 16 with a star, question 17 with a star type thing, because go back and rework those. Work as many as you can to kind of see if it's a problem that you had a problem with. You need to go back because you've got to be able to see the math behind it to kind of understand, okay, am I fully understanding? Because 1 or 2 is not going to really check your understanding. You know, if you do about 3 or 4 on something that you had a problem with and you're like knocking them out, then you're okay. So
my problem with these last couple of ones I just realized were because like in 17 we times times the denominator by itself, the 2y times 2y, and in this one, since it was cubed, I guess we did 4y times 16y.
Yeah,
I think that's where I got confused because I didn't know whether to do it by 4y or something that both 4 and 5 were divisible by.
Yeah, that's the thing. And that's why if you look right here, and I'll highlight it, if it's something other than a square, then I'm going to write out the powers of it, right? Those numbers raised to that power to kind of help me to see what I need to multiply 4 by to be something. 4 times something can't give me 1. I guess I could have done it by 2, right? That would have been 8. I could have done it by 2. It would have been a little bit less, right? I saw 64 instead of 8. So you could have worked it with, just instead of multiplying it by the cube root of 16 y squared, you could have done 2 cube root of 2 y squared. That would have made it a little less. This right here would have been a little less complicated.
Because 4 can go into 8.
Yeah. Well, I could take something times 4 to get 8, right? And 8's a perfect cube, and so is 64. And 4 times 2 would give me 8, but 4 times 16 would give me 64. So those both are correct paths, right? Both forks will get me to the right place. It's just when I chose the 64, I had a little bit more math to do. I had to simplify it, right? If I'd have just chose 2 to make it 8, then this up here would have I would have kind of not had to do this, right? Up top. It would have looked more like the blue and the black and the purple right here. Because 2 times 5 is 10, right?
Right.
And I wouldn't have had 16 times 5. So it just things to consider. Square roots are easy because you're right. You just take what's under there and multiply it, and it's going to create a perfect square because you're multiplying it by itself. So a little bit easier.
That's definitely what I was messing up on.
Yeah, the cubes and the 4th roots, that's what you got to consider. You just, what do I need to multiply the number by to get me a perfect cube or perfect 4th to a power of 4, and then look at your variables. I need to make those in multiples of 4s or 3s, depending upon what I got. So, all right.
Yeah, thank you. That makes a lot more sense.
Yeah.
I
Okay.
think I was messing up on that same thing too. Oh, that helps. Thank you.
No, it's like I said, it's unless you've been exposed to it and it's readily accessible. Um, those type things that jump, because guys, we are making a huge jump when we
Yeah.
introduce things. It's like shoo, we're doing several years in about 10 minutes.
Yeah.
So
So I know, like during the homework, sometimes I get stuck on a problem and I'm staring at it for about 30 minutes. So that link that sends it to the instructor, like we can use that. We can.
yeah,
I didn't know if that was something that we need to be using.
yeah, you can use that. You can send that specifically to me. Sometimes students will text me and say, "Hey, I sent you one in XYZ.
Okay.
Can you look at it?" And if it's normally, I'll just take a snapshot of it and write on it with my phone and send it
Uh-huh.
back. Or if
Okay.
it's something that I feel like it's better just to explain it, then
Mhm.
I'll say, "Hey, can you take a call?" And I'll just call you and say, "Hey, this is," or I'll work it out and then call. Yeah, there's multiple things I do with that, but
Okay.
sometimes I have the luxury of that, and sometimes, depending upon where I'm at during my day, I don't. But
Okay.
that's the tendency what happens. So,
All right. Thank you.
all right, any more off this section? 1.3.
I think that's going to help us get through that one. So.
All right, y'all want anything in 2.4?
I think I'm good on that one.
Actually, 19. Just that's my last one.
On 1.3?
Yeah.
Okay. Let me go back
Just
in.
make sure I'm all good.
All right,
I
so
think
that's
that one might be a little different too. Yeah. It's got all this.
well. What do you think 9 should be multiplied to give you a perfect cube? Aaron, what do you think 9 should be multiplied to get you that perfect cube to rationalize it? It's okay to say I don't know. So,
I'd have to think about it for a second. Go on the calculator.
all right. So, what I would have if I were you, I would have these written down on note cards. I'd have my perfect squares, right, which are pretty simple. I'd go up to probably about 25.
Would it be 3?
Yeah, because 27 is a perfect cube, right?
Yeah, gotcha.
So just knowing that, um, and I can't simplify anything in between like we did on the previous problems, like earlier in the HEP session. So I'm going to do 3 and then z squared. Does the z squared make sense?
So
Yeah,
you can get z to the third.
Yep.
Okay.
Yeah. The variables have to be in multiples of what the root is. So if the root is 3, then I have to have multiples of 3, 6, 9, 12, those type numbers for it to go evenly into to pull it out, right? So this is going to give me the cube root of 27z cubed, and then up top that's 48. That's cube root of 48, x to the fourth, x, y, and then z. So let's consider some things while I'm cleaning up that. Let's see, is 48? No, 48 is not. So that would be 2 cubed, 3 cubed, 4 cubed. That's 64, 27, and 8. All right. So I know that this is going to drop here to 3z, right, on the denominator. Now, let's look at the numerator. And then I'll do, I guess I can do the the variables after that. So I can rewrite as cube root 8 times cube root of 6, right? 8 times 6 is 48. And then this would become 2. Now I got cube root of 6, right? And 6, there ain't nothing going to that. Now for this would be, I could bring one of them out, right? So it would be, I could bring, let me change colors to green. I could bring one X out with one left. I can totally bring out a Y, total, all of them. And then I can't do anything with the Z squared, right? So what I've got sitting up here is 2xy cube root of 6xz squared. And I can't simplify the numbers out on the outside, and I can't simplify the variables on the outside, and I'm done simplifying my cube root. So this would be your answer. Now, that's a meat and tater type problem. That's a lot of stuff going on.
Yeah.
That looks a lot better than.
Yeah.
Like, my problem was not knowing what to times the denominator by.
Yeah. And that's why I'm putting these down on a note card so that you could quickly get to them when you're working a cubed or a fourth root. Then you know what you're trying to achieve, and you're not having to, yeah, it didn't take but just a couple of seconds to write that down, but you're looking for time savers. You're looking to work more efficiently, so that you make sure that when you're doing the test, you are able to get through it all. So hold on, let me do something. Okay. All right. What else would you like?
I think that'll give us a good foot in the door.
Yeah, I'm with Amy. Those are my big problems. Everything
Yeah.
else is all right.
It's just my brain just wasn't going in the right direction. Like, I just sit there and look at it and not know which way to go, but this does help. So.
I didn't even attempt 19, honestly, because by the time I got to it after missing 15, 16, 17, like all those, I was like, okay, I got to ask about it.
Yeah.
Yeah. All right. I'm trying to find another day besides Sunday. Sundays are good. Don't get me wrong. But I'm trying to also find y'all another day so that you at least have me twice a week if you need it.
Okay.
So I need to see how much I'm finishing one particular project, so my time is about to free up on some stuff. So I just got to make sure that I'm not overextending myself before I commit to time. So, all right, what else, girls?
I think that's going to be it for tonight. I really appreciate you helping us do that.
Yeah.
Yeah, thank you so much. We appreciate it.
Did y'all? Let me pause this.